Hello, this is a tutorial I'd like to talk about using Viverse and how to generate much better shadows and lightings using an app called playcanvs, which is a web-based game engine. You can publish a model directly from playcanvs into Viverse. So here you can see I have a temple which I have a lighting created inside. So you can see the real-time shadows from this yellow light. If you do not using Play Canvas, just using the default Viverse is a little bit difficult to create this kind of lighting effects. So Play Canvas would be a better choice. And also if I go closer here, you can see here's another lighting. I'm able to generate the shadows. If I get closer, I'm able to see this transparent kind of like a wire mesh material I can see through. And also I have this 360-degree image to show the whole panorama. And also here I have this I call the Zaha tower. This is a tower generated by AI as well. So if you recall the last tutorial, we covered how to use an image to 3D generate this geometry. The same thing for this temple. This is done through Nano Banana. So I create isometric view. Then I'm able to transfer this model from image to 3D. We use Trellis, and then I'm able to bring that into Viverse. And also you see some particle system. Okay. Yeah, so I will show you the whole process how you can use Play Canvas to push a model to Viverse. So before I do that, just a quick note. The previous tutorial how to generate this tower from image to 3D. I hope you have time to watch. And also this is a Nano Banana. You can use an image generate the isometric view. Then the view can be used to create a 3D model. I did not really polish this model in Rhino, so this looks still kind of like a random triangles. So it's not like a Zaha tower has been cleaned and optimized, but this is a process you can get a model. The 3D environment was generated also through an AI image. So you can see this one is actually pretty awesome. So the way I did is using Hunyuan 3D. Hunyuan 3D is another pretty cool AI. You can upload an image. This is called reference image, and then you can generate the entire 360. If you don't use Hunyuan 3D, you can still do the panorama image, but you probably want to use the stable diffusion plus LoRa, which allow you to do 360. So if you're interested about that approach, go ahead and watch this tutorial. You will have the whole step-by-step instructions how to do it. But I think Hunyuan is actually pretty cool. Generate the image very fast, and there's a consistency. Okay, so I think that is all the elements. I will showcase a little bit how you can create this from scratch. So the first thing I want to do is I want to go to playcanvas.com. This is a place you can just create a new project. The interface is very similar like Unity. If you have ever used Unity, you will see it's pretty much the same. Once you have the first Play Canvas project created, actually I can show you how to do it from scratch. Is very straightforward. So when you set up account, just make sure you have the same user account as your Viverse. Otherwise, later they cannot communicate, right? So when you create your user profile, then this is the place you are able to create a new project. I start a project with a empty template. So that is a few, blank template you can use. I think this one works pretty well for me. Once you create this first project and you assemble something, and later just make sure you install the um, connections, or we call extensions, so you have the bridge connecting these two programs together. So I will show you really quick. If you Google playcanvs2viverse, you can find a download page where you need to download extensions for Chrome. Once you download this extension, I will probably put a link here. Let me just do this really quick so you know the whole process. Yeah, just simply Google play canvas to viverse. Right, that's it. And then this is a tutorial how to set up the connection. So this is through the extension, and here is the link. You basically just need to download this zip file. Once you download zip file in the Chrome browser, you need to go to extensions and manage extension. Right? We'll manage, you want to load unpacked, and then just point to the unzipped file to complete the installation. Once you install, you can see this is a viverse play canvas extension. Make sure the developer mode is on. Once you have this extension established, just make sure you refresh your browser, you log into the viverse, right? Just make sure you are inside your viverse. This is me, same user account. And also in Play Canvas, I have exactly the user account. You probably want to refresh once you install the extension. And then here on the left, you can see you should have this connection. But for some reason, if you don't see the connection, no worry, just refresh and then click login. Once you log in the viverse, you can see this triangle setting. That means right now you are inside. You are making the connections successfully. Okay. So once you have the connection, then you can use publish, and then you are able to publish the model directly into viverse. That's a really cool way. You can have a lot of freedom to create details. Okay. So the next one, I will talk briefly how you can create some details. First, on the left, this is actually the main kind of hierarchies of all the objects I created in the stage. And you can definitely create a new one. You can create 2D, 3D, right? You can create particle system. That's the one actually inside the temple, right? I have this particle system created right here, right? So this is the hierarchy. In the middle is a working place. And at the bottom, this is your kind of library. This is called asset, right? And then on the left is the property panels. You can see the details of each object. So for example, if I pick up this object, right, this is the temple I transferred from AI. So here is the scale, rotation, position. These are some details, right? And sometimes you want to check the static. You want to make sure this one is receive shadows, right? So that's it. That's the objects, right? The way you can bring 3D objects into Play Canvas is very straightforward. So first, you can go ahead, create a folder. In the folder, then you can upload the object. The objects I can bring in is FBX, GLB, OBJ, just all the common geometry format you can load it in. So if I take a look at this temple, so this is called base. When you bring this FBX in, it's automatically carry the material with it. And then you are able to control the color, you can control the diffuse. These are the properties you can manipulate. I did exactly the same thing. In fact, here if I right click, I can actually see this is the geometry. This is a 3D model. This is the GLB. The GLB file is actually automatically generated whenever you bring FBX into playcanvs. So it's pretty cool. If you open in the viewers, you can actually see this model in 3D. As you can see, I did not really optimize the model, so it looks pretty random in terms of the tessellation. Okay, yeah, but that's okay. Just want to show you. If I take a look at the Zaha Tower, right, this one, I can use F to feed into my view. Oh, by the way, you can use WASD to navigate. If you select objects, just left click, and then you can use your right mouse button to change the view. It's kind of identical to Unity and Unreal. It's pretty handy. And also you have this manipulation uh, gizmo. You can move. Um, you can also type scale, rotation. Keep in mind, when you drag these objects in, sometimes you create a hierarchy within the object. So here, the way I add a Zaha Tower is I go ahead, add entity, right? And then I can drag this entity under the root. And I give this name, for example, this entity, I want to give name called tower, right? And then I can right click, I can change this to template, add instance, right? And then I can point to, let's see, for example, 3D uh, Zaha Tower, okay? So by doing so, I create a reference to the original model. The benefit to have an instance is if you have 2 or 3 or 10 towers in the game, they all reference to the same parent, right? In asset library, it's pretty efficient. It doesn't really, cost too much power to compute. This is true if you have a forest, right, with hundreds of trees. All the trees is actually referenced to the same parent. So this is called instant. Okay. You can also do is duplicate this, right? So when you duplicate, you will have another version here. And then each time you just move them a little bit. This is a quick way if you don't want to, uh, drag this every single time. Just create one and then duplicate. Just keep in mind is whenever you bring objects in, they may be inherit out hierarchies. So some of this scale settings probably is very small. In this case, you probably want to reset this value. Okay. So this value is inherited from some, depends on which program you bring in. This one is from Rhino. So it inherits some of the settings from the Rhino geometry. But that's a tower. So here I will go ahead delete because I don't want to have too many towers here. All right, so back to this tower model. You can see this one is referenced right here. So that is the tower looks like. If you are curious what exactly is this tower looks like, you can always click the GLB file and then you can open in the viewer. Then you can see the 3D model. As you can see, this was generated by AI. I brought into Rhino. I did a little bit quad remesh and sub-D. And this is actually a polymesh converted from a sub-D model. That's the reason you see the tessellation looks pretty uniform. I really like that. You can definitely manipulate. The setting here is very active, but that's okay. I just want to show you this model looks pretty nice, very smooth. Okay, so I brought this Zaha tower in. Once you have the tower in, you can definitely manipulate the materials. This is very standard for all the program. I think you're pretty familiar. Diffuse control the color, but also you can control the specular, which can mimic the metal material, so you can actually play with it. There's also some special material channels such as emissive, opacity, I'm pretty sure you guys can check it out. Okay. So that is about the Zaha Tower. So I will show you another one I did is the ground. We call the plan. For this plan, besides is the basic default geometry, I created two components. First one is called collision. Another is a rigid body. This is very important when you create something to prevent the players to falling down, right? So just make sure in the rigid body I did this as static, and the collision I have to set up the extent. So this actually define the boundaries of the collision box. So here, for example, if I change this from 30 to 60, right, you can see the extension of this box. Right, this basically define the ground holding the player. So make sure you do the both collision and rigid body. This can be added just by add component right here. The same thing I did this for the wall. So this is a box. Right, I create this box by 3D box. Once you have a box, then you can manipulate their scale, right? Position them in the right place, and then add a collision, and then add a rigid body as well. Because I'm not moving this box, by force, so you can just simply check this as a static. But this could be dynamic if you want to, simulate something like bouncing around. Okay, so that's about the wall. You do see the wall has a special material. This is one called floor. The way I created this kind of wire mesh, I think this is a standard practice. You probably already know this in Rhino and other program I taught before. So in opacity, I have this black and white image. I call the blend as alpha. If you have no idea what is alpha, just Google. This is a channel can simulate the transparency. You want to make sure you know this one is made in the playcanvs natively, so it has a UV mapping. But if you bring some geometries from another program, they probably do not have a UV mapping, so you have to do it by yourself. I would recommend any objects they should have a UV map. Okay. Again, if you're not sure what is UV map means, just Google my tutorial in Rhino, how to create a UV map for geometry. So here is the material. And this material, if I open it, you can see I have the diffuse color, which is floor. Also, I have this opacity blend as alpha. Because it's black and white, you can definitely use in RGB. But if it has a alpha channel like a PNG file, you can use A, means alpha. It should be the same as a black and white. Okay, so that's the reason it looks like a see-through. For the floor, it's very simple. I just adding a really simple diffuse map directly to the diffuse channel. In the specular, I think I could check the metallic, so make it looks more like a reflective. I don't know. I just feel maybe glossiness, maybe metallic. You can play to get more polished floor. But I think I like this no reflections. I think that works fine for me. Just keep in mind this floor looks a little bit flat, right? Because there's no shadow. But if you really get close, you will see the shadow show up. So this is something very standard. By default, you have a sunlight, which is a direction light, which you can check the casting shadow, affect dynamic. You can change color, you can change intensities. Besides the sunlight, I create two omni lights. So here's one. I use F, zoom in. So this color is orange. I make a little bit higher intensities for this guy. And I check this as a static. I checked bake light map. So this can actually bake light map if needed. However, I think at the end I didn't really bake any light since all the objects is still kind of dynamic. It taking the light calculation in runtime dynamic lighting. It's a little bit more expensive, but it's okay. So here I will show you. If you don't want to do a runtime lighting calculation, you have to check light mapped to bake the light. But you see the light looks like a little bit fuzzy now. But I kind of don't need the light map baked because I wanted the, when you have avatar walking on top of the floor, I want to see the dynamic shadow. So baked light won't give you that dynamic shadow anymore. Yeah, I just uncheck the bake light map. All right, so that is basically all the geometries here. Oh yeah, the last one, the sky dorm. So this is one I actually created just in Rhino. This is the sphere. This sphere actually has a reversed. Actually, I brought this right here, 3D skybox, right? So this is the geometry. It looks like a sphere. I can actually show you. Open viewers. Okay. And this sphere is actually reversed. So that means um, the sphere will be visible from outside. Okay. Um, will be visible from inside. Sorry. Um, okay. So that is reversed sphere. You can check my tutorial how to create this sphere in Rhino. Just reverse normal or flip the face. Okay. So this is a sphere. And then I have this material. This material is the 360 image from Hunyuan 3D. I just brought in as a PNG file, right? And then with a PNG, I can double click. You see, this is a PNG file. It's a eco-rectangular 360 image, panorama image. So this image I applied to the diffuse channel. Okay. Also applied to the emissive channel. The reason is I want the skylight actually be able to cast illuminations, right? So it's not, receive any shadow. It's a lighting resource as well. And here I check the UV channel. You have to get a UV channel for the sphere, otherwise the mapping will not look right. Okay. Color intensity, I kind of make the light a little bit brighter, but you can definitely manipulate these values. I don't know. You can make a very dramatic effects. I think 2 should be fun, or maybe 3. Okay, to give it a little bit brighter kind of look. Also, you can change the color. I will leave that to you. Okay, so I think that is pretty much about the sky dorm. Yeah, for the sky dorm, I changed the scale to 555 to make it relatively large. So it's actually covered the entire stage. Okay. I think that's pretty much about everything I have done here. Just to make the demo more interesting, I will just add a few more particle system maybe. So here I will add another particle system. Okay. Okay. So this particle, where is it? You can actually select and then use F to zoom in. Okay, it's here, it's in the middle. So this particle system, again, you can play with all the settings here. I will just leave as a default. I make the particle here kind of floating in air. Yeah. So you have some particles in a space. Okay. And I will create another lighting. So root. Maybe I will just go to the light and then create a light. And I won't use maybe just Omnia light as well. Maybe spotlight this time. Okay. So here's the spotlight. I will just drag it here as a children. Okay. And then use F. You can fit in. Okay. So this is a spotlight. I can just move up a little bit. Right. And then I will maybe make the spotlight, rotate a little bit. So here, if I choose rotate, I will say rotation maybe along this axis. I can just drag my mouse to change the value by kind of slide up and down. And I want to give intensity to be higher, just make it dramatic. Range is fine, fall off is fine, linear corn, outer. I probably want to increase this value a little bit, so it has like a soft fade out, right? Because inner outer will create this kind of fade out effects. I think this blend pretty well with the shadow. Okay, yeah. So this is something you can really easily done in Viverse directly. So I would recommend to do it in Play Canvas. So once I have this lighting, I think I'm pretty happy with it. I just want to make sure, you could casting shadows, but this could be a little bit, expensive in terms of frame rate. So if you don't really, need to compute the shadow, you can disable casting shadow. So that could save a little bit GPU. For the floor, you see, I do not check casting shadows, right? Because there's nothing under the floor. Yeah, there are some tricks you can definitely play. So that's a spotlight. So once you're happy with this spotlight, you can definitely right click, duplicate, right? And then I can move this light here. So you can have another light and maybe duplicate one more time, right? And then have another light here. So keep in mind, the more lights you have, the more expensive for computing. So here I have multiple shadows overlapping with each other. Yeah, in the ideal game, I probably will disable the shadow. Let's do this, yeah, to not compute the shadow for every single one. So not casting shadow for this. The second one, not casting shadow. Okay, so only in the one in the middle has a shadow computed. Yeah, that looks fine. All right, cool. So I have a bunch of lighting here. What else I want to cover? I think that's all good. Maybe I will just create one more light for the Zaha Tower. Then we're done. So here I will go here, add another light, Omni light. So this Omni light I will move. Right. So you select first, then F to find. F means fit the selection to the screen. So here's the light. If you can't really see it well, just increase the intensities, right? It's pretty obvious. And then I change the color, just make it a little bit dramatic, maybe, I don't know, green. Okay, so I have the green light, cool. And then I will move the green light, maybe close to the Zaha Tower, right? You can use F, right? So you can see there's a little bit washed green um, close to the tower. I will probably make this a little bit higher. Yeah, it's a little bit tricky to move. You have to find the correct axis. Yeah, so you have the green light here. I probably don't really worry about the shadows. I will not checking the casting shadow. It's a little bit cheaper, right? Not casting shadow. Okay, so I have this some dramatic lighting effects for the tower. I don't know, maybe just keep it here. What if I change up? Can do both. I don't know. Looks good here. All right, and I make the range a little bit larger. Okay, right. So it's kind of travel to a longer distance. That looks pretty awesome. All right, so I have this green light. I'm pretty happy with everything. Keep in mind, Play Canvas automatically save your file. You don't have to save manually. Yep, and I'm ready to publish. Okay. So if you have published this model before, so here you can just simply click publish, right? And here you can do publish to Viverse. So this will push the whole model there. It will actually overwrite the previous one if you already published earlier. That is the thing I really like, is you don't have to generate each time a new file. You just overwrite the old one. So you can do preview, you can see the level directly in Viverse. Okay, see. So this time I should have some green light. I should have some pretty cool spotlight near the entrance, right? That looks really nice. So here I can move, right? I can see the spotlight. You do see this spotlight is actually casting the shadow, but if I go here, right, this spotlight does not casting shadow, and this one does not casting shadow. So just keep in mind, you probably don't want to have too many lights casting shadow. It's very expensive. You see the particles. That's really awesome. And then if I go to the middle, I think I put some particle here as well. Yep, you see the particle is right there in the middle. And then if I look at the tower, I think it's the other one has a green light. Yes. So here, run to the tower, right? And I see some pretty cool green light. If I'm using V, I can see the green light right there. Awesome. All right. I think that's pretty much what you can do with Viverse. So if it is the first time you transfer Play Canvas to Viverse, you do want to create a word, right? Give a name, but you only need to do this once. In the future, when you republish your model from Play Canvas to Viverse, it automatically overwrites the previous one, so you don't have to create a word anymore. Okay. I think that's it. That's all about how to transfer your model. It could be AI generated. In this case, it's Nano Banana, or Trellis, or Meshy, or Triple. Yeah, I didn't create the collision here on this edge, so you want to be careful. You could die. If I go here, I'm falling down. Oh, it's regenerated. That's funny. So here, if I do run to this edge, right, I have a collision, I have a rigid body, I'm not able to go through. But you can see the transparency map. But here, if I go to this edge, there's no collision, so I could falling down. Okay, and respawn. That's nice. Yeah, I think that's all about the Viverse. So just let you know, uh, once you create a word, right, they will show up in my profile word. This will be show up here. I give the name Temple 2. So in the future, if you want to share with other people, you can click share. At this point, this model is unlisted, I believe. So yeah, keep that in mind before you complete your model. You want to keep your model as unlisted, not public. Okay. Uh, yeah, so that is just some minor things. This is unlisted. All right, I think that's all about how to post, how to stream, how import your geometries into Play Canvas, use it as a kind of Unity or game engine, assemble everything, then publish the model directly into Viverse to make this as a true multiplayer metaverse. Okay, that's it.